Welcome back. Problem 11-19. So statement is if A is equal to 3 inch and wood has an allowable normal stress 1.5 psi and allowable shearing stress of 150 psi. Determine the maximum allowable value of P acting on the beam. So you can see this is a simply supported beam made up of wood that has cross section is width is A and height is 2A, and that is acted upon by load P. This would have allowable stress, bending stress is 1.5 psi and allowable shear stress is 10 psi. So you have to find the largest value of P that can be applied on this beam. So let's start with the solution. So we know that maximum bending stress is equal to moment into C divided by I, and this moment is maximum moment, and similarly allowable shearing stress is equal to V into Q divided by I into T. So we need maximum shear force and maximum bending moment that can be find by using the shear force and bending moment diagram. So we'll first draw that, and we will get maximum moment and shear force. For that I will need this reaction force if we remove this support. So definitely there will be a reaction force. Let this is R1 and 0.1. If you remove this roller support, so definitely you will have a reaction force R2, and let this is 0.2. Now by using equilibrium condition that sum of all moment about 0.2 is equal to 0 and taking the counterclockwise movement as positive. So about 0.2 we have one moment is P into perpendicular distance is 3, and that is counterclockwise, so it will be positive. The second moment will be P into perpendicular distance is 6 feet, clear, and that will be also counterclockwise, so it will be positive. The third moment is R1 into perpendicular distance 9, and that will be clockwise, it will be negative. So I will write them one by one. P into 3 plus P into 6 minus 9 into R1 is equal to 0. So it means that 9P minus 9R1 is equal to 0. So from here you will get R1 is equal to P. Similarly, you can apply another equilibrium condition that sum of all forces along y direction must be equal to 0 and taking the upward force as positive. So R1 minus P plus R2 will be equal to 0. So R1 is P minus P plus R2 is equal to 0. So from here you will get R2 is also equal to P. Now you have these reaction forces, so you can just easily move to draw the shear force and bending moment diagram. So what we will do is that we will draw a vertical line from here, from the end of these beams, clear, and then horizontal line to draw the first shear force diagram. This represent length of beam in feet, where we have V, clear. Now each division is equal to P, so this is 2P. Similarly this is minus P, you can choose your own scale, minus 2P. Now at this point you can see that we have R1 which is equal to P. So first point, our first point will be this one. This will be your first point. Now moving from R1 till this point P, we have only P. Now at this point we have minus P. So plus P minus P is equal to 0. So it will move to this. This will move to 0. Okay. Over the length of 3 feet. Now moving from this point till further 3 feet. So there is no load. So this will be 0. At this point we have a load of minus P, so it will go to minus P, and then further no load, so it will be there. Now at this point we have R2 which is plus P, so it will be 0. Okay, so this is your shear force diagram. Now we will draw the bending moment diagram. So bending moment diagram will be just like if you draw horizontal line, similarly moment and x in feet. Okay, so the first area under the shear force diagram is 3p. So at a length of this we have 3p. So let's select, let this is 1.5 and this is 3p. Clear? So first point will be your this one, and the bending moment will be a straight line because shear force is a horizontal. And here you can see the shear force is 0, so bending moment will be same 3p. Also this area which is equal to minus p into 3. So it will be minus 3p. So plus 3p minus 3p will bring it to 0. So you will get the bending moment like this. Now from shear force and bending moment diagram, you will get maximum shear force is equal to P. If you take either mod, so it will be equal to P, and maximum bending, absolute maximum bending moment is equal to, you can check it, that is 3P. So you have both this value. So we'll move further and we will use this formula. Maximum stress is equal to maximum bending moment into C divided by I. Since we have been given the cross section of this beam, so A is, this width is given as A, which is 3 inch, and height was 2A, so 2 multiplied by 3 is 6 inch. So total height is 6 inch. So this is the cross section. So its neutral axis will be this one, which will be 6 divided by 2. So it means that this is your C, and this C is equal to 6 divided by 2, which is 3 inch. So C is equal to 3 inch. Okay, 3 inch. Maximum moment is equal to 3P. Clear? And this 3P, the unit will be into kips into, the unit will be in pound into feet, let's say, because this will be, okay, we can use kilo pounds. Kips into feet, because the allowable stress is in KSI. So kips into feet. So if you convert it into inch, so 3P into 12 is equal to 36 kips into inch. So I will also write it over here, that is 36, and the unit is in kips into inch. Now we do not have I, so I for this rectangular cross section is equal to 1 over 12, its width, which is 3, and height is 6, so 6 cube. So when you solve this, you will get it 54 inch power 4. Okay, so you can just put it in this formula. Maximum stress, which is given as 1.5 KSI, 1.5 into 10 raised to power 3 is equal to maximum moment, which is 36 kip into inch, multiplied by C, which is 3, divided by 54. And there is a P as well, 36P. This is 36P, and this is also 36P. So when you solve this, you will get P is equal to 750 pound. Clear? Now this is the P, so we will get confirmation whether it satisfies the maximum shearing stress or not. So for that, shear stress, so we know that maximum shearing stress is equal to maximum shear force into Q divided by I into T. So V is given as P, so P is 750 pounds what is Q? So Q is equal to A into Y dash. So what is A? A is the area about the neutral axis. So this area is, this is distance is 3 and this is also 3. So 3 multiplied by 3, which is equal to 9, and its centroid distance from neutral axis till its centroid, which is equal to 1.5. 3 divided by 2 is equal to 1.5. So I will write it. Area is equal to 3 multiplied by 3 and y dash is 1.5. So this is your Q. I is also available. I is equal to that we have calculated was 54 inch power 4, and T is equal to 3 inch, this one. So you can just put the value. Maximum shear stress is 150 psi. So 150 is equal to 750 into Q is 3 multiplied by 3 into 1.5 divided by I, which is 54 multiplied by 3. So you can see that 150, this is the maximum. Okay, so you can see that maximum shear force based on maximum shear stress based on maximum shear force comes out to be 62.5 psi, and we have allowable shear stress given in the data is 150 psi. So maximum shearing stress is less than allowable, so it means that this P is equal to 750 pound can be applied on this wooden beam. So this was all about problem 11.19. I hope you have enjoyed this. Those who are new to my channel, then subscribe it and press the bell icon so that you can get notification about my latest video. If you have any question, you can ask me in comment section. Thank you for watching.